idea. Now this person, let this person, let him jump. Any person you can make it jump. So mass is m3. This mass is, I'll do one thing, m1, m2. First he will jump, no? Let him m1. The other person and the trolley will recoil back. Call this as velocity VA. V0 will take it. So let the person velocity here UR, let he will have velocity V1. Again the same method. Net force acting on system is 0, so initial momentum equal to final. Before that, we'll make analysis. Anything directed towards right, let it be positive. So minus UR is equal to minus V1 plus V0. I'll put VA something. No? V0 again, you'll think initial. I'll locate the sign according to the convention. So this will be, we wanted V1 equal to VA minus UR. Let's apply conservation of linear momentum. Initial momentum equal to final momentum. Initial momentum 0. Persons and trolley are at rest. Final momentum m2 plus m3 into VA. That is towards right.
Sir, V1 equal to UR minus VA, sir.
V1 equal to UR minus VA. Okay, V1 I'll send it to LHS. No, UR minus VA. Okay, yeah, thank you. Okay, now let's substitute all the values. So m2 plus m3 VA. V1 is UR minus VA. So VA is equal to M1 UR by M1 plus M2 plus M3. I think there's a generalized thing. Please do remember every time need not to solve. What is the velocity? What is the recoil speed of the trolley? Mass of the person or mass ejected into the speed with which the mass ejected with respect to system by total mass of the system. This is a generalized thing all. Okay, but our problem is what now? So the trolley will recoil. Now look at the second person. So what he's going to do? He's going to jump now in the direction of motion of trolley. So after, now the second person is going to make a jump that one. Let's take the second situation. These are very basic. Most of you might be knowing. Just recollect once all the ideas. Huh? This is something very important, basic fundamental. So let the what action the trolley. So let me say V, and the person is going to make a jump like this. Is m2. Its velocity is UR. Let V2 be the velocity. So trolley should recoil back. If I get V negative, I'll change direction. Getting the method. So trolley should recoil according to the concept. Okay, let's assume towards right. I'll solve the problem. If I get negative, I'll change the direction. Then before second person making a jump, before second person making a jump, what is the initial momentum of system? M2 plus M3 into VA. This is what, and we know value of VA. How to get this relationship? Again, the relative velocity ideas plus UR is equal to plus V2 minus plus V. So we are interested to replace V2, no? So UR plus V equal to V2. Check once. Look at the signs there. Anything directed towards right, positive. Now, applying conservation of linear momentum. Before second person making a jump, so what is the momentum of system? M2 plus M3 into VA. Now finally it is M2V plus M3. So V2 is unknown, VA is already we know. So substituting V2 from here, we'll get the required answer. Let's see that what happened to V, less than VA or greater than VA. That's what we are trying to learn here. So M2 plus M3, VA is M1 UR, M1 plus M2 plus M3. M2, this will be UR plus V. I think some big formula will come. M2 plus M3.
M3V, sir.
Huh?
M3V, sir.
M3V, yeah, simple. M2 plus M3 M1 UR whole divided by M1 plus M2 plus M3 minus M2 UR, I'll bring it. So this will be equal to M2 plus M2 M1 UR plus M1 M3 UR. I'll write in next step. This will be M1 M2 UR, one M1 M2 UR get cancelled. So M1 M3 M2 square UR. Let me better expand here. M1 M2 UR plus M1 M3 UR, M1 M2 UR, M2 UR plus last will be M2 M3 UR all divided by M1 plus M2 plus M3 is equal to no M1 M2 UR, M1 M2 UR, this will get cancelled out. So the final answer V will be M1 M3 plus M2 M3 M2 square UR divided by M1 plus M2 plus M3 by
Sir, shouldn't it be minus
negative
of the
negative signs. Negative signs. I'll take it here. Yeah. Whether it will be positive or negative, how to V will be less than V or greater than V. So for that you can do one thing. Assume some value M1 equal to M, M2 equal to say like a 2M or M2 equal to M, M3 equal to some 4M. Check it. You get exactly some relationship between VA and V. So I'll just leave it to you. M1 equal to M. You can discuss all the cases here. The first case, mass of the trolley, let it be 2M. Second case, M1 equal to M, M2 let it be 2M. Check, substitute all the values first in VA, then check in V, check V less than VA. In all the cases what happened, V will be less than VA. And it may come negative also. It may come even negative also for certain value, and for certain value of M2 it may be 0 also. This is very important. That's why I took the values here. So for certain value of M2 it can be 0 also. Okay, no, so just do analyze. Until unless you don't analyze, clarity will not come. But altogether, I can say that V should be less than VA, and it can be negative also. Any reason for that? Because like if a mass ejected in the direction of motion of system, if a mass is ejected in the direction of motion of system, the complete problem I'll present it. If the mass is ejected in the direction of motion of system, then what should happen to the velocity of the speed of the system? Must decrease here. If the mass is ejected in the direction of motion system, the speed of the system must decrease here. So I'll generalize. Okay, fine. So let me go for the thing. So what actually is, if a system say m naught, it is moving with a velocity say v naught. If mass is ejected in the direction of motion, so it will be m naught minus delta m. Now, what will happen to some mass is ejected? Then what will happen to the velocity? The velocity v1 will be less than v naught. If the mass is ejected in the direction of motion of system with a speed u r relative to the system, with that one, the speed will decrease. So now if it is like this, this is m naught, this is v naught. If the mass is ejected opposite to motion of the system, then v2 greater than v naught. So how to increase the speed of the system? If you eject mass perpendicular to direction of, if you eject mass opposite to direction of motion of system, then so what will happen to the speed of system will increase. If the mass is ejected in the direction of motion of system, then the mass what happen, the speed of the system will decrease. Sir, what happens if I eject perpendicular? It can also happen. That I'll discuss in the coming numericals. So here what will happen? The mass, let it be ejected like this. Then it will continue. It will have v1x and it will have v1y. So it will try to move in this direction. So how to increase or decrease the speed of system? By ejecting some mass. How to change direction of system? Again by ejecting mass. It is a very, you can say, beautiful part of conservation of linear momentum, what you are going to conclude. What is the purpose of doing all these numericals is to conclude this one only. Okay, no, so what is you are the speed with which mass ejected relative to the system. There's a conclusion of that one. Okay, no, you do try this. Huh? It's a one question, cases 1 and 2 I put it, no? Check in both the cases what will happen to like a V1, V2, final velocity of trolley compared to that particular thing, compared to that VA1. So what you are supposed to do, VA1 and V1. Similarly here, second case it is VA2